Students, this is the question 4 in our question video series. Let's look at the question. A medical investigation claims that the average number of inspections per week at a hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim at a 0.05 significance level? Very first, when you look at the questions, what you know, n is equal to 10. And for that sample, mean number of infections, x bar, is equal to 17.7. And the sample standard deviation they have given us, s is equal to 1.8. Okay, next, look at the claim. A medical investigation claims that the average, so our population parameter is mu, number of infections per week at a hospital in southwestern Pennsylvania is 16.3. So claim is mu equals to 16.3. This time our claim is this one. It has the equal mark. Write down the symbolic opposite of the claim, that is mu not equal to 16.3. Among these two, you should find out what is the null hypothesis and the alternative. Because the first statement, according to the question, it is the claim, it has the equal mark. So that is our null hypothesis. The other one is the alternative hypothesis. Okay. According to the symbol in the alternative hypothesis, because it is not equal sign, our test is a two-tailed test. Next, which distribution should we use? Sample standard deviation is given. Sample size is 10, that is less than 30. We can suppose that number of infections per week is normally distributed. So according to that one, we can get the t distribution. In order to take the decision, reject null or fail to reject null, we can follow two methods, critical value method and the p-value method. Before going to that one, we should find out the test statistic value. So this is the equation for the t-test statistic. Substitute the values you have. Okay, x bar is 17.7. Mu is something we should put from the null hypothesis. Here, this time we have null hypothesis 16.3. So mu is 16.3 here. Divide that 1.8 divide by square root of 10. So for this one, you will get the answer 2.46. Okay. Next, we should find out the critical values. Let's look at the t-table. Because this is a two-tailed test, go to the two tails row and alpha is 0.05. Select that column. And our degrees of freedom is n-1, so 10 minus 1, that is 9. Go through that row and find out what is the value for two tails 0.05 column and the 9 degrees of freedom. That is 2.262. Because we should have two critical values for a two-tailed test, here 2.262 and here minus 2.262. So if our test statistic is going to fall into the right side to the 2.262, this region is the reject H0 region. And even if the test statistic is going to fall the left side of the minus 2.262, that region is also the reject H0 region. The other area in between minus 2.262 and 2.262 is the fail to reject H0. Okay. Now our test statistic value is 2.46. Definitely it falls into the right side of the 2.262. That means the rejection region of the H0. Then our t-test statistic falls into the right side of the 2.262. That means the test statistic falls into the rejection region. Therefore, decision is reject H0. Okay, that is the decision here. Now let's look at how we can do this one using the p-value method. Okay, our test statistic value is 2.46 and the degrees of freedom is 9. We should find out where 2.46 is located. Okay. Go through that degrees of freedom 9 row. It is between 2.262 and 2.821. Okay. The test statistic value is between these two values. Go to the two tails values. Those are 0.05 and 0.02. So the p-value is equals to 0.05 plus 0.02 divided by 2. Why we divide by 2 is we think that 2.46 is midway between 2.262 and 2.821. So that value is 0.035. In order to take the decision using p-value, we should compare the p-value with significance level. Here, the significance level is 0.05. Definitely you see that p-value is less than alpha. Therefore, we reject H0. According to this one, there is enough evidence to reject the investigator's claim. Okay, let's meet with another video soon.